Hello and welcome. And you have yours. Fantastic.
Hello.
So I'm now here with the representative from Team Bumblebee.
That's correct.
And what is your name?
My name is Ananya. We're from National University of Singapore.
Absolutely. The storied and infamous, I think you're moving even into the famous Bumblebee at this point.
That's very flattering. Thank you. We just try our best every year.
Absolutely.
Yeah.
Last year's winner, returning again with the same vehicle.
Right, yeah.
Can we talk about what are some of the, what's the team looking to accomplish this year?
Okay, so we've made some software upgrades. We're using a lot more machine learning. And we're also doing segmenting, which means we align onto the obstacles. We're leaving it more towards the ML and search patterns rather than waypoints. Yeah. So that's some of the software upgrades that we're trying to test out. Definitely more risky, but I think it pushes our capabilities. So yeah, you're going to see that in this run.
Fantastic.
Yeah.
So now what that sounds like to me is that when you go from one part of the course to another, you're not just going to a specific endpoint, saying, hey, go into this area, right? Perform some type of inspection, and then once you find something that's familiar, all right, well then you'll start to engage with that specific target once you find out what it is.
That's correct, yeah.
Okay. So now in doing that, I think it requires a good bit of foresight and of planning, maybe even some simulation, but certainly a lot of water time. And so how have you been able to create these software changes?
So our software team is always hard at work, and we've been, testing since January. So January to May is our semester at university. So we get about 1 to 2 days per week, the entire semester, and we have like a 10 to 5 slot for testing. So essentially we're constantly testing throughout the semester, but obviously it's just like once or twice a week. And that helps us like stabilize things. And when it comes to summer, it's crunch time. So we initially started with about 3 days a week and then ramped up to 5 days a week. So yeah, as you said, just a lot of water time.
So now, how many hours? Just doing the head math right now, that's a staggering amount of testing that you're looking at.
That's right.
How many hours do you think that this vehicle has been in the water this year?
I'm going to be honest, I have not done the math. Yeah. But yeah, if you think about 8 hours of testing 5 days a week for even like a month, that's already like 240 hours. Yeah. So yeah, we've just been like going at it for as many hours as possible. Even here in San Diego, we have a very kind host who has offered her house to us and has a pool, so we're able to constantly test then. So yeah, just constant pool tests.
Fantastic. And so I think an interesting thing with these competitions is I'm not sure that there is a ceiling, right, on what really can be done, because certainly the course has, there are the different challenge elements, but as a team and as a competitor that has come back and said, okay, well, you won last year, you have another vehicle that's looking dangerously good. The question becomes, well, what processes are you going to now refine? And if you're testing in the water for 240 hours minimum, there's deeper levels of detail that are required, where now there's logistics required to surface that vehicle, right? Where I think if I guess what I'm getting at here is there's that next layer of systems engineering where you might start to see parts failure because they're just been and not because because something's going wrong, but just because it's reached its usable life. So have you seen any sorts of problems like that?
Yeah, definitely. That's right on, actually, for some of the issues we faced here in San Diego. So we've had this vehicle for quite a while now, and definitely learned a lot about, life cycling, the parts that we have. Obviously, if it's an off-the-shelf part, it's easy because it comes in the spec sheet how long you can use it, right? But with our manufacturing parts, especially our batteries, that are very critical parts, we've seen some failures. It's just sort of things that this year has revealed because we're pushing the vehicle to its limits in terms of testing hours and the time it has existed. So these are things that we would keep in mind in the future. Yeah. Luckily, none of the problems were unfixable. So when our batteries had fractures in their latch, we used a new mount to secure them in place, and we're always iterating, we're always fixing things. So yeah, things are looking all right. But yeah, definitely lessons for next year.
So now internally with this type of vehicle, do you have just, do you have spreadsheets with part numbers? Like how documented and cataloged is the system at this point?
I think our documentation is constantly going for improvements. Yeah, we're always trying to get our members to improve their documentation. We don't have detailed Excel part numbers, but rather with each competition year, we prepare spares, and those spare lists provide a pretty good BOM for our vehicle.
Sure.
Yeah, so that's how we go about it.
Yeah. Fantastic. So kind of one of the things we're so interested in is how has this competition impacted your engineering education?
A lot. I think this competition forces students to think about, apply their knowledge a lot more than university courses do. Like we have smaller design projects in school, but they never come to this level of testing, of lead times, of preparation. So yeah, I think my engineering sense and just my technical skills developed a lot being part of Bumblebee and going for these competitions.
Yeah, I mean, I think a senior design project or a capstone design project is nothing new in engineering. But typically 3-5 person teams, and maybe you have some specialized programs that are larger, but certainly for many of the teams at Robosub, and as the vehicle is now underway, we'll come back to that question as we see. And remind me, does the vehicle have a name this year?
So we just call it AUV 4.1 based on the iteration we're at. Yeah.
Cool. AUV 4.1 is now engaging in the style points. Okay, and we have seen AUV 4.1 perform a rotation and then has gone through the left side. I believe that's the Earth.
Yeah.
Yep. So you're staying on this planet during this run this time?
Yeah, I got to stay grounded,
Yeah, absolutely.
Yeah.
Was there, I think there's almost a philosophical question on that of which route the teams want to go through. Is there any thought to it?
I don't think so, but yeah, I think it makes a good metaphor. Got to stay grounded, got to stay on Earth.
Now we are seeing it within inches of the surface, but it dives back down, keeping us all biting our nails. But yeah, I wonder if it'd be an interesting question to ask if, hey, just some teams happen to stay on Earth, or some are intentionally going over to Abydos. But so now, where is AUV 4.1 going next?
It's going to be going over to the Buoy.
Yes.
And we'll be attempting the Buoy task and going over to the 2 Earth symbols. Yep.
All right. So now it is in that region.
Yep.
It looks like it has detected the buoy.
And that's the first one.
And it has made contact. It does look like that is the Abydos symbol. And again, another another contact with the. So can you go for all 4? Okay, so it has made those 2 contacts, and it looks like now it is perhaps moving on. Where's it going to next?
So we're gonna be doing the random pinger task, which will bring us to either one of Torpedo or the octagon. Yeah.
And I think it's, let me also be one to say, AUV 4.1 just went over. It did detect that dock, and it's, made pretty quick determination to go and make those targets, and to make that type of contact is still fantastic.
Yep, that's right.
Okay. I wonder if we're getting some advanced notice of which random pinger is active by what we're seeing on the camera feed right now.
Yeah.
So just a little bit about that. Why don't you tell us about the vehicle's approach to that random pinger engagement?
Right, so we've got 4 hydrophones on board, which are going to be used for the random pinger task. And if we get the octagon task, it's going to go in surface only. It will do the bins task after that, and then, do the remaining picking up. Yeah.
Okay. I know you guys had spent a good bit of time this week trying to engage those chevrons.
That's right.
And so it's just a strategic decision for finals? You're going to surface? So
the way to go is we'll attempt one of the tasks and then go back to pinger and then go and do the other task. But yeah, we will be attempting the chevrons because our strategy, as always, is to attempt all tasks. Yep.
Fantastic. Yeah. And so now it looks like the vehicle is looking for that octagon.
That's right.
Now, during the practice events and during the semis, were you able? I know the chevrons are tricky. You guys thought it was hard last year with the water bottle.
Yeah. So the actuation, we usually have 1 or 2 people assigned to actuation only, and that's because actuation
Just to take a pause, it looks like we do have a surface in the octagon. Congratulations.
Thank you.
And so go on.
So just as last year, we have an actuation person who was constantly iterating on the suction cup design to pick up the chevrons. So yeah, we've been iterating like right up until the semis. So yeah.
And so I believe that I was told that there's a novel design to it where it's a one-way valve. That it's pretty much a passive suction cup for those chevrons.
Right. Yeah. So we've got a one-way valve that's connected to the suction cups, and the way it engages with the chevrons is it uses the suction cups to catch on to them. That's basically the idea of it. Yeah.
It's a nice mechanical solution. It doesn't need to be overly complicated.
That's right.
Fantastic work. So now we are going over to the Stargates, to the Guldak Challenge. Guldak. I think by the end of this commentary, maybe I'll actually learn how to say the name of this challenge, the Guldak attack. So you have a couple of different torpedoes, Now, what's your strategy for this challenge?
So we're planning to hit them in the right order. So it's going to attempt both torpedoes, big and small. So yeah, align both times and shoot them. Yeah.
Fantastic. Now, you have used a number of different advanced technologies on board your system. I think last year your torpedoes were a pretty special type of 3D printed filament.
That's right.
Could you remind us what those are?
So we've done MJF torpedoes this year. They're a two-part assembly. So we've got an O-ring that captures air so that the torpedoes can resurface after they've been shot. Yeah. So we had one guy just working on that CFD to make that torpedo look real smooth and real hydrodynamic. Yeah.
And it looks like there has been a successful shot. I did see a torpedo on the other side of the open gate drifting up.
Yep.
Now let's see for the closed gate. And it's gone through the upper hole as well. Fantastic. And we can see, as you said, those torpedoes with the air captured internally floating on up to the surface. Nice environmentally conscious of you to let us easily retrieve.
Yeah, gotta be besties with the divers, so don't want to give them too much trouble.
Absolutely, yeah. They appreciate that. So now it looks like we are moving back to engage the chevrons.
Yep, that's right.
Okay. Actually, I think I was thrown off by the camera, but we're going down for those bins.
Yeah, my bad. So the way it's gonna go is we've had this pinger switch. Mm-hmm. So we're gonna go attempt the bins task, and once that's done, we're gonna head over to the octagon again.
Absolutely.
Yeah, to attempt the hardest task.
Yes.
Yep.
Yeah. Okay, so now your vehicle is going down, it's finding these bins.
Yep, that's right.
And so now it's going to try to interact with that handle. So what type of work has the actuation team done to move this handle off of the bin?
Okay, so the way it works is we've got a claw on board, which is pretty much the same as last year. And yeah, the lid has been taken off.
You have gotten the lid.
Yep.
Moving it off to the side.
Yep, that's right.
It's now dropped and free. Fantastic.
Yep. We've got a compliant grabber so that if it gets stuck somewhere other than the lid, it doesn't stall the stepper and put load onto our actuation board.
That's a really nice resiliency piece there. Some forward thinking, creative solutions.
Yep. I think it's more of all the failures from the testing that have brought us to this design, but yeah.
The old Edison line, he didn't learn how to make a light bulb, he learned 9,999 ways not to make one first.
That's right, yeah.
Looks like another lid has successfully been picked up by that compliant grabber.
You can see the grabber moving.
Mm-hmm. Reminded me of the, claw machines.
Yeah, actually the design visually is quite similar. But we've fine-tuned it for the lids so that it works best. Yep.
Fantastic. So now as we see the vehicle looking to drop the markers.
Yep, that's right.
So now, as this vehicle is making its way through the Transdec facility here at Nywick, what type of differences have you encountered? Now you've competed in, Bumblebee has competed in, of course, a Robosub in Maryland, a Robosub at Nywick. You've competed in Robot X events. What do you see as something at Transdec that maybe sticks out from the other competitions?
So I think mainly we test in a pool, which is a normal university pool that doesn't go too deep, doesn't go as deep as 5 meters even. So I think one of the challenges is like the visibility is a lot different. We're lucky that the visibility here is not too bad, but it's definitely a different environment from working in a pool. The deployment is a lot different as well. So we've got deployment plans and we've got roles assigned to help that as well. Whereas the logistics for a pool is a lot different. And obviously our sensors are working harder in an environment like Transdec than at a pool. Yep.
Yeah. And I wonder, I'm curious how the acoustics works for your team here. I think you guys were hard at work last year with your music algorithm in that pool at Maryland with just those sheer walls. All these types of multipathing and reflection. Now, Transdec is designed to be an acoustic test environment, but it's very, have you seen any impact there for your acoustic sensor?
So we have a pretty similar algorithm as last year, and yes, I think Transdec is designed for acoustics to work a lot better. So we had one guy who was just crunching away at the acoustics. We had some trouble with our hydrophones here and there, but we're always planning for spares, so that wasn't too much of an issue.
Fantastic.
Yeah, so we've got them working, I think, for this round. Yeah.
And now it looks like 4.1 is back at those octagons and ready to engage with the chevrons.
Yep, that's right. This is the most nerve-wracking part.
Oh, yeah. I think you might hear a collective gasp if it gets one of those from the audience. Everybody's waiting with bated breath right now.
I'm gonna tell you straight. I think the rest of our team is waiting with their breath held as well.
So now, a lot of the rest of the movements from 4.1 have been quick, decisive. Now it really looks like it's taking its time here. What decision making is going on?
So essentially, it's just trying to align to the chevrons and go down and descend to collect them. Yeah, sometimes the aligning takes longer, and we want to make sure that we get the chevrons correctly. And obviously, we've used segmentation, so it's looking at the orientation and such as well. Yeah, our suction is also not mounted at the center, so yeah, it probably plays into the aligning that it has to do.
Moving itself just to. You don't want to center the vehicle on the chevron, of course. You want to center the suction cup on the chevron.
That's correct.
Now, so there's 4 that are available, right? So there's a bit of a randomness to this task. How do you decide which one to go after first? Or do you?
I don't think that. I believe there's. The way that it goes is it aligns to one of the chevrons and picks it up. Yeah. So I don't think that there's a particular strategy on which one to go to first. Yeah.
Sure. It says, hey, here are the chevrons that I see, and there's probably some array that those locations are in, and whatever order that array gets populated, you just go after it in that order.
Yep.
Yeah, very cool. So you don't get a vehicle that performs at this level without overcoming problems along the way. So how has your team, is there anything specifically that you can think of that you had to come up with a creative solution to figure out?
Well, it's related to this task right here. It's the suction cup. We actually had a whole other design right before we landed San Diego. We had a gripper design that used a peristaltic pump, but when it didn't have enough time for integration because building over the semester takes time, and the person designing has to juggle a lot of things. So we were hitting it quite close to the deadline. But when we came here, we realized that it puts a lot of load on our actuation board, which would compromise the vehicle's ability to do the other tasks. So it was a very difficult decision, but we decided to scrap the peristaltic pump and start a completely new design. So this suction cup has actually been iterated on and produced in San Diego.
Wow.
Yeah, so definitely one of the hardest ones to do. Making it easy to deploy and not interfere with, say, the grabber task or any of the other bottom-facing tasks was definitely a challenge for our mechanical team. Yeah.
Yeah, it's really that complete systems integration piece where you can't just make one thing in a vacuum. It has to not interfere with the rest of the systems that have been so expertly designed.
Yeah, that's right. Yeah.
And so now you said that you're iterating on that in San Diego.
Yeah.
I'm guessing, well, I wouldn't be surprised, but I'm guessing you did not bring a machine shop with you, but you have some 3D printing capabilities.
Yeah, we've got a 3D printing guy who has helped us a lot. He set up 2 printers for us, and it's definitely helped us do all of the fixes here in San Diego and continue iterating on the suction cup. Yeah.
Very cool. Do you have a particular filament, or do you think your 3D printer guy, does he have a particular filament that he prefers?
So we use PLA for the most part because it's easy to use.
So I believe that is time. A fantastic run from AUV 4.1, and congratulations
Thank you
on
so
another
much.
great competition.
Thank you.
Yeah. But before you go, anybody that you would like to thank or any shout outs for back home?
Oh, yeah. We've got a 30-member team, and so every one of them has worked real hard on this vehicle for many, many years, even the seniors. So we've had this vehicle for a really long time. Definitely want to thank them. And also our sponsors. Definitely couldn't have gotten here with all of their support. A lot of our sensors, our manufacturing, our PCBs. We've got lovely sponsors that believe in us and have brought us here. And our faculty at NUS that continues to support us. So yeah, those are some of the people we'd like to thank. Yeah, thank you.
Wonderful. Have a great afternoon.